Let's take a moment to talk about designing visuals and visual variables. When you're designing your graphs, part of your design process should include considerations for accessibility. According to the Canadian Armed Forces medical standards, between 8 to 10% of males and almost 1% of females are color deficient in some way. Even if your viewers are not color deficient, they may reproduce your visual on a printer. In other words, they take your PDF and print it out on a black and white or monochrome printer. Let's look at an example where only color is used to differentiate data meaning. So if we look at smoking rates in Canada by year, we're differentiating between smokers and lung cancer deaths only by color. Now, if you happen to have a color deficiency, you may not notice the difference between the two line graphs. One of the lines is a dark green and one of the lines is a dark red. If we take this same image and we simulate a red blind or red deficient protanopia, we see that it's almost impossible to distinguish the difference between these two line graphs. So viewers who are red blind or red weak may not be able to figure out which of these lines represents smokers and which represents lung cancer deaths. Even if our viewer was not color deficient, our color choices already are low contrast between each other. Depending on the screen you're looking at, it might have been hard to differentiate meaning between these two line graphs. If we take that same image and strip it of color data, so this is how the image would look if it was printed out on a printer that only supported grayscale. So there's no more color data. There are some viewers out there who have a condition called monochromacy. In other words, they cannot perceive color. For viewers who can perceive color, if they print out your visual on a black and white printer, and that is most office printers or photocopiers, you lose all color data, and it's almost impossible to differentiate between these two line graphs. So what can you do to compensate? Well, we can make a change. The only change I've made to this graph is to adjust the lung cancer deaths color to be less saturated. It's as if I took the intensity of the color and turned it down. We've gone from a dark red to more of a pink hue. So the top graph is the unmodified version, and our bottom graph simulates a red blind color deficiency. So notice now, because we have more of a contrast between our two lines, we can use contrast alone to infer the meaning of each of our data lines. And even if we apply a monochrome filter, the contrast is still enough to differentiate meanings between our two lines. But these are not the only visual variables that we can manipulate. So we can also manipulate the size of our lines. We can adjust data marker size. We can adjust line thickness. We can use different markers to represent different data types. So in our example, by adjusting our line thickness, our marker size, and our marker types, even if somebody is deficient in the colors that you have chosen, they can still infer meaning between the two data sets by looking at the marker sizes, by looking at the line thicknesses, and potentially, depending on your choice of shades or your choice of hues, they can infer meaning based on contrast. When you're designing your visuals, try out color deficiency simulators. There's many of them online. I've included a link from pilestone.com. Consider whether your visual is one that will be printed out. So apply a monochrome or a black and white filter to your visual to see what will it look like when printed out on a black and white printer. And finally, you can go to the NIH website to learn more about the different types of color deficiencies. Some other design considerations to keep in mind are some recent research that suggests that the human brain can detect meaning and process images within 13 to 80 milliseconds. What that means for us is that a well-designed visualization can say or communicate an idea faster than we can speak to somebody. If only there were some rules that we could follow that would help us design good visuals. Thankfully, the author Nancy Duarte of Slideology has 5 data slide rules. Tell the truth, get to the point, pick the right tool for the job, highlight what's important, and keep it simple. When you're designing your visualizations, think about what your key message is. Do you want the audience to see trends over time? Do you want to guide your audience to a conclusion? Do you want your audience to make comparisons between 2 data sets? What are your most important pieces of data to communicate? So you can use contrast to de-emphasize items that are not so important, and then you can increase the contrast on items that are crucial to your message. Another principle to think about is there an item in my visual that's distracting? In other words, does this add noise? Does this detract from the message I'm trying to communicate? And finally, do you find yourself saying, "as you can see," or explaining a visual out loud? If that's the case, the visual you're presenting might be too complex. It might be time to simplify. Let's take a look at a few examples. In the first example, we're taking a look at youth crimes by severity in Central Ontario. The author wanted to demonstrate that youth crime was up in the province of Ontario. At the moment, we see break and enter, serious violent crime, and drug trafficking. There's a lot of data on the screen. What we're most interested in seeing how much serious violent crime is going on in Ontario by youth. If that's the case, then break and enter and drug trafficking are only adding visual noise. So if we remove those, we're left with this bar chart. Now, since it's only serious violent crime that we're reporting on, we could say take serious violent crime, put it in the title in Central Ontario, and add an annotation beside our slide to communicate our point. However, we want to compare 2005 to 2011. In other words, the change over time. So in that case, the years 2006 to 2010 are mostly noise. So if we remove those from our visual, reduce the contrast on 2005, and perhaps highlight the most important metric, which is violent crime by youth has increased by 51%, by making the 51% very large, and in the same color as the 2011 bar graph, we can communicate even more meaning. Let's look at another example, because you can also think beyond the bar chart. In this fictional made-up example, we see that on average, 3 out of 4 people like beards. Do we need a graph to communicate this visual? Not necessarily. This is where you can use iconography. You can also use other visual variables, such as space and grouping. Notice how the 3 individuals with beards are kind of grouped together, and the 4th individual with a mustache is shifted over to the side. When you're designing your visual, you can use something called the rule of thirds to help guide the viewer's eye. Notice how I've divided my screen into a 3x3 grid. I can use these intersection points as areas where the eye will be drawn to. It can help me lay out items on my slide. Another visual variable to take a look at is contrast. Let's take a look at differing levels of luminance for a solid black piece of text. On the left, I have a 10% gray piece of text, and at the very bottom right, I have a 100% full black, full darkness piece of text. Depending on your monitor, it will depend on your monitor how much of a difference you see between the different percentages of black. For example, I have a monitor that I'm looking at as I record this session where the difference between 85, 95, and 100% is imperceptible. I can't see the difference. I do have another monitor that I'm looking at where I can see the difference between 70, 85, 95, and 100%. We can do the same thing with colors. So here's a range of different shades of blue. So this is just modifying the luminance of my color. So at 10%, the blue is almost hardly visible, but at 100%, it's quite visible. Now what's neat is that you could pick, say, 3 or 5 shades of blue to create a color palette. If you pick blue 20%, blue 50%, and blue 90%, you could convey meaning of 3 sets of data safely. And you could use the 90% shade, for example, to call attention to your most important points of data. You can use it plus size and thickness for emphasis. So contrast, size, the rule of thirds, reducing noise, these are all elements that you can take into account when you're designing your visualizations.